Our galaxy is a vast and mysterious place. It's filled with billions of stars, each with its own story to tell. Some stars shine brightly while others are dim and difficult to see. Some stars are alone while others exist in groups bound together by gravity. One such stellar family is the Gliese 667 system, located just 22 light-years away from us in the constellation Scorpius. This system, with its 3 stars, has captured the attention of astronomers worldwide. Why? Because one of its members, a red dwarf star named Gliese 667c, holds within its gravitational embrace a fascinating collection of planets, some of which might be capable of supporting life. Gliese 667c is smaller and cooler than our Sun. It emits a faint red light, a stark contrast to the brilliant yellow of our own star. Despite its diminutive size, Gliese 667c is a captivating object for astronomers. This red dwarf star is thought to host up to 7 planets, making it a treasure trove for exoplanet hunters. What makes Gliese 667c even more intriguing is the presence of what astronomers call super-Earth's planets larger than Earth but smaller than Neptune, within its habitable zone. This zone, also known as the Goldilocks zone, is the region around a star where temperatures are just right for liquid water to exist on the surface of a planet, a key ingredient for life as we know it. The discovery of planets beyond our solar system, known as exoplanets, has revolutionized our understanding of the universe. It was once thought that planets were rare occurrences, but we now know that they are incredibly common. In fact, astronomers estimate that there are more planets than stars in our galaxy. The search for exoplanets is driven by a fundamental question: are we alone in the universe? Finding planets in habitable zones is a crucial step in answering this question. These planets, with the potential for liquid water on their surfaces, represent the best chance for finding life as we know it. The concept of a habitable zone is based on the principle that life, as we understand it, requires liquid water. Too close to a star, and the intense heat would boil away any water on a planet's surface. Too far away, and the water would freeze solid. The habitable zone, therefore, represents a delicate balance, a region where temperatures are just right for liquid water to exist. Finding planets within these zones is a top priority for astronomers. Among the planets orbiting Gliese 667c, one stands out as particularly intriguing: Gliese 667cc. This super-Earth, with a mass several times that of our own planet, orbits within its star's habitable zone, raising the tantalizing possibility that it could harbor life. What makes Gliese 667cc even more fascinating is its likely state of tidal locking. Tidal locking occurs when the same side of a planet always faces its star, much like how the same side of the moon always faces Earth. This phenomenon has profound implications for the planet's potential habitability. Imagine a planet where one side is perpetually bathed in sunlight, while the other is shrouded in eternal darkness. This is the reality of a tidally locked planet like Gliese 667cc. Such a scenario would create extreme temperature differences between the two hemispheres. The day side would be scorching hot, while the night side would be frigidly cold. However, despite these challenges, some scientists believe that life could still exist on tidally locked planets. They speculate that life could adapt to the extreme conditions, potentially thriving in the twilight zone between the scorching day side and the frozen night side. While red dwarf stars like Gliese 667c offer the potential for habitable zones, they also pose significant challenges to the development and sustenance of life. One of the most significant threats comes from the intense bursts of energy known as stellar flares. These flares, far more powerful than those emitted by our Sun, can have devastating consequences for any planets orbiting close to the red dwarf. Imagine a sudden surge of energy, a blast of radiation that could strip away a planet's atmosphere, leaving it vulnerable to the harsh conditions of space. This is the destructive power of a red dwarf flare. These flares are not only powerful, but also frequent, posing a constant threat to any life trying to gain a foothold on nearby planets. The intense radiation from these flares could damage or destroy any nascent life forms, making the development of complex life a daunting challenge. Section 5, a cosmic balancing act, life in a crowded system. The Gliese 667 system, with its 3 stars and multiple planets, presents a stark contrast to our own solar system. The planets in this system are locked in a delicate gravitational dance, their orbits influenced by the gravitational pull of multiple stars. This complex interplay of gravitational forces creates a chaotic environment, raising questions about the long-term stability of planetary orbits within such a crowded system. In our solar system, the planets follow relatively stable and predictable orbits around our single star, the Sun. This stability has been crucial for the development of life on Earth. However, in the Gliese 667 system, the gravitational tug-of-war between the 3 stars could lead to significant perturbations in the orbits of the planets. These perturbations could cause planets to collide with each other, be ejected from the system altogether, or even spiral into their host star. Section 6 Gliese 667 CE and CF More possibilities for life. While Gliese 667 CC has garnered much attention as a potential haven for life, it is not the only planet in the system worthy of our curiosity. 2 other super-Earths, Gliese 667 CE and CF, also reside within or near the habitable zone, further fueling the excitement surrounding this intriguing star system. Gliese 667 CE and CF, like their sibling planet CC, present both opportunities and challenges for life. Their presence within or near the habitable zone hints at the possibility of liquid water on their surfaces, a crucial ingredient for life as we know it. However, they also face the same threats from red dwarf flares and the chaotic gravitational environment of their crowded system. Nonetheless, the existence of these additional planets within the habitable zone underscores the potential of the Gliese 667 system as a target in the search for extraterrestrial life. Section 7. The Cosmic Mirror, Reflections on Life's Existence. The search for life beyond Earth is not merely a scientific endeavor but also a philosophical one. The possibility of finding life on other planets, even if it is microbial in nature, would have profound implications for our understanding of our place in the universe. It would challenge our assumptions about the uniqueness of life on Earth and raise profound questions about the nature of consciousness and the meaning of existence. Imagine the impact of discovering even the simplest forms of life on a planet like Gliese 667 CC. Such a discovery would shatter our cosmic loneliness, demonstrating that life is not a fluke but rather a fundamental process that can emerge under the right conditions, even in the most unexpected of places. It would force us to confront the possibility that we are not alone, that the universe is teeming with life, and that our pale blue dot is just one of countless worlds where life has taken hold. Section 8, A Universe of Wonder, The Enduring Quest for Life Beyond Earth. The search for life beyond Earth is a journey into the unknown, a testament to humanity's insatiable curiosity and our desire to understand our place in the cosmos. It is a quest driven by the belief that we are not alone, that somewhere out there amidst the vastness of space, other forms of life may exist, waiting to be discovered. This search is not only about finding life but also about understanding the fundamental nature of life itself. Every new planet discovered, every tantalizing clue we uncover, brings us one step closer to answering the age-old question, are we alone? The quest for life beyond Earth is a journey of exploration, discovery, and wonder, a journey that has the potential to transform our understanding of ourselves and our place in the universe. It is a journey that reminds us of the power of human curiosity, our innate desire to explore, and our enduring fascination with the unknown. Section 9. Conclusion. Our place in the cosmic tapestry. As we continue our exploration of the cosmos, discovering new worlds and unraveling the mysteries of the universe, the question of our place in this grand cosmic tapestry becomes ever more profound. The study of star systems like Gliese 667c, with its potential for harboring life, serves as a stark reminder of the vastness of the universe and the countless possibilities that lie hidden within its depths. While we have yet to find definitive evidence of life beyond Earth, the ongoing search continues to inspire and ignite our imaginations. The journey itself, with its inherent challenges and potential for groundbreaking discoveries, is a testament to the indomitable human spirit and our unwavering quest to understand the universe and our place within it. The search for life beyond Earth is a journey that transcends scientific inquiry. It is a journey that speaks to the very core of what it means to be human.